Hi everyone, today we're talking about geometric solids and 3D shapes. As a reminder, you do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember, you can pause a video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Be careful though, make sure you don't fast forward too much that you miss out on something important. Okay, so as a reminder, so far we've talked about just 2D, two-dimensional shapes. So when we're talking about SpongeBob versus Doodlebob, so far we've just talked about Doodlebob. We talked about 2 dimensions, length and width. We multiplied length times width to get the area inside a flat shape. Now we're talking about SpongeBob. We're talking about 3-dimensional shapes. So shapes that don't just lay flat on a piece of paper. They have depth. So meaning if you were to think about SpongeBob, SpongeBob is a sponge that you can squeeze, while Doodlebob is just a picture on a piece of paper that you can just lie flat. So 3D shapes are what we're talking about today. There are 3 main parts to 3-dimensional shapes. They are the face, the edge, and the vertex. They are very important words that you're going to be using in our lesson, so be sure that you jot this down in your notebook. A face is a side on the shape. So usually, and we'll talk about exceptions later, usually creates a flat 2-dimensional surface. So it's like your 3D shape is made up of 2D shapes on each of their surfaces. So if you think about SpongeBob, it's like he has a sheet of paper on each of his sides, while Doodlebob just has the one side. So a face, you can think about like anywhere that SpongeBob can have a face. You can have a face in the front, on the side, on the back, on the top, on the bottom. Those are all faces. So it's a side on the shape, and it creates a flat 2-dimensional surface. An edge is where 2 faces meet up, so it creates a line. And then a vertex is a corner on the shape where 3 or more faces will meet up, so they're going to create a point. So a face creates a 2D surface, like a piece of paper, an edge creates a line, and then a vertex creates a point, so it's getting smaller and smaller and smaller. Be sure that you have those vocab words written down. So here are some examples of what we mean. Like we said, a face is a smooth, flat surface. So in this shape here, the purple is a face. In this green shape here, what's written in yellow is a face. So it's a smooth surface. And then in this third shape, the dark blue is a face. An example of a face. So it also labeled all the other faces as well that you can see. So a smooth 2D surface is a face. An edge, like we said, is where 2 faces meet up. So it's going to create a line. So if you think about somebody standing on the edge and looking over, that's like an edge. This red line here. The edge is over here. One example of an edge. There's tons of edges. Any of these lines where the 2 faces meet up is an edge. And then these are all edges as well. And then lastly, vertex is the point that 3 or more faces will meet up. It's a sharp point. So all 3 of these drawings show you the face, the edge, and the vertex. You can choose any of these drawings to draw. I just want to show you different examples. You don't have to draw all 3, but choose one that makes the most sense to you, or is maybe the easiest for you to draw. The other thing that we didn't talk about earlier is that the plural of vertex is vertices. Okay, so if you're talking about more than one vertex, you're talking about 2 or more vertices. So that's just the plural of it. It's not vertexes, it's vertices, okay? So again, make sure that this is in your notebook before we move on. Okay, And then when we talk about geometric solids, there's three main families of geometric solids. The first family we're going to talk about is called the prisms family. These are three-dimensional shapes, and here are some examples of prisms. Something you probably noticed is that they kind of look like they're stretched out shapes. So you'll see that they have the same two-dimensional shape for both of the bases, the end faces. So here's a triangle for this end, and then there's actually another triangle on the other end. You just can't really see it. There's a square on this end, a square on the other, rectangle on this end, rectangle on the other, pentagon on this end, and a pentagon on the other, a hexagon, six-sided shape, on this end and on the other, an octagon on this base, eight-sided, and an octagon on the other. You don't need to draw all of these. The other thing that you probably notice about the prism family is that they all have flat rectangular side faces. So there's the shape at the base, and then the sides are all rectangles. Rectangle here, rectangle here, rectangle here, rectangle here, rectangle here, rectangle here. So this is what we mean by it looks like a 2D shape, like this pentagon, but stretched all the way out. I like to think about it like a Spam can or a huge pile of Post-it notes. It's just like the same shape, but just like layered and layered and layered on top of each other. Okay, so that's what the prism families have in common. They always have the same shape on both ends, both of those bases, and then they always have a bunch of rectangles on the side to make it look like it's stretched out. So the formula for naming them is, if you think about them having a first name and a last name, their first name is always their base shape, and then their last name is always prism. That's why they're part of the same family. This is like the prism family. This is triangular prism, because there's a triangle on both ends. This is square prism, square on both ends. This is rectangular prism, pentagonal prism, hexagonal prism, and octagonal prism. Okay? They all have the same last name, which is prism. But their first name tells us how unique they are, their bases. I have a red arrow pointing to triangular prism and rectangular prism because those are the most common prisms that you'll see. The other ones are a little more rare. The most common ones are the triangular prism because that one kind of looks like a camping tent. And the rectangular prism is actually found everywhere. So it's like tissue boxes, normal boxes, any kind of box is a rectangular prism actually. And triangular prisms are actually like those Toblerone candies. Love those. So those two are the most popular ones. Again, make sure that you have this jotted down before we move on to the next family. Okay, the next family is the pyramids family. So they are also three-dimensional shapes, and they have things in common. So they are always going to have one base. The prisms had two bases, right? One on each end. But pyramids only have one base. They kind of sit on one base. And that base is going to be a particular two-dimensional shape. It's the bottom face. And then their sides for the pyramids are always going to be flat triangular sides. And they're always going to all join at one point. You would think that this point is called a vertex, but pyramids are fancy. Their one point at the top is actually called the apex. So another vocab word for you. So similar to the prisms, all their sides are one particular shape, except in this case, all their sides are triangles instead of rectangles. And just like the prisms, each member of the family has a first name and a last name. Their last name is all pyramid, and their first name is whatever the base shape is. So this is triangular pyramid. The base, the bottom, is a triangle. This is square pyramid because the bottom is a square. This is rectangular pyramid because the bottom is a rectangle. Pentagonal pyramid has a pentagon on the bottom. Hexagonal pyramid has a hexagon on the bottom. Octagonal pyramid has an octagon on the bottom. But again, all of them have triangles on the sides, leading up to one point, the apex. Square pyramid is the most famous out of them because they are everywhere. If you think about the pyramids in Egypt, those are square pyramids. The other ones are not as common. Okay, so that's the pyramid family. Be sure you jot that down before we move on to our last family. Okay, so now we're going to talk about the last family, which is the curvilinear family. They are not like the other two families. They don't share the same last name. They have few things in common, but they're still a family. They're all three-dimensional shapes. They all have curved faces. If you remember before when I talked about faces, I said that faces are usually going to make flat two-dimensional shapes, but not in the case of the curvilinear family. Their faces are curved. So if you were to take a cylinder, which is like a soup can, in your hand, and you were to smooth your hand around the label of your soup can, your hand would curve. If you took a basketball, which is like a sphere, in your hand and smoothed around that face, your hand would also curve. Same with an ice cream cone. Your hand would curve around that ice cream cone, which is why we use them for ice cream, because they're easy for us to hold on to. So that's what the curvilinear family has in common. They all have curved faces. And then they may or may not have vertices or faces. Or edges. So that was a typo there. They may or may not have vertices or edges. So if you notice the sphere, it doesn't have any edges. It's just one smooth face. It also doesn't have any vertices. There's no points anywhere. The cone has all three. It has faces, edges, this edge around here, and then a vertex. But the cylinder has no vertex. There's no pointy ends. It does have two edges and obviously some faces. Okay, so it gets a little weird with the curvilinear family. Another thing that they do have in common, though, other than the curved faces, is that they all have a circular cross section, meaning if you were to cut into the shape, you'll see a circle. Like if I were to take the soup can, the cylinder, in half, I would find a circle. If I were to cut the sphere, or like a basketball, in half, I would find a half circle inside. Or half of the sphere would have a circle inside. And then same thing with the cone. If I cut it at different places, I'll have smaller and smaller circles when I cut into it. All three of these have red arrows pointed to them because they are all important and common: cylinder, sphere, and cone. So like I said, the cylinder is like a soup can, sphere is like a basketball or even the globe, and then the cone is like, an ice cream cone or sometimes a party hat. Okay, so that's the curvilinear family. Be sure to jot that down. We're going to do some examples before we end. All right, so the first type of problem that you could be asked is just to identify parts of a shape. So in this problem, for instance, they're asking how many vertices does the following shape have? Go ahead and pause your video and try it on your own first. Okay, you should remember that vertices are like points. They're corners. So I'm circling all my corners. 2, 4, 6, 8. Looks like there's 8 corners, 8 vertices. Okay, so all those problems will have you identify parts. The next type of problem is just asking, do you remember the names of the 3D shapes? So that's why it's important for you to know how each of the families call themselves. Unless it's the curvilinear family, then you have to know all those special names. So this one right here is a cone. The easy thing is the cone is easy to remember. It's like an ice cream cone. Sphere and cylinder are a little harder to remember. Okay? Let me know if you have any questions as you work on these problems, and I'll see you in class.